Hi guys. So what I wanted to do is go over some of the harder problems from the most recent homework assignment. Just because I don't think we had enough time in class to go over a few of these, and I wanted you guys to see some worked out examples. So this first row here, all is going to follow the same idea. So what I'm going to show you, number one, there is a difference between these two expressions. The first one, you are squaring the entire log base 3 of x. That means log base 3 of x times log base 3 of x. Okay? Whereas the other expression, you are just squaring the argument of the log. So that is log base 3 of x times x. Okay, so that's the difference between those expressions. On the second expression, because the exponent is on the argument, you can follow those log properties and you can move that to the front. So now what we're looking at, I'm going to go ahead and move that 3 over and set it equal to 0. This now looks like a quadratic equation. So what I'm going to do is I'm going to replace, like we did with those e to the x problems, I'm going to let log base 3 of x equal u. So I'm going to plug in u and make this u squared minus 2u minus 3. And then I can factor. So then I get that u is equal to 3 and u is equal to -1. Now I don't care what u is though. I need to know what x is. So I'm going to go back and replace u with log base 3 of x and log base 3 of x. And now I can just solve each of those equations. So 3 to the third is equal to x. 3 to the -1 is equal to x. So my two possible values here would be x equals 27 and x equals 1/3. All right, we're going to use the same concept on number 2. That is a question you can factor because I can replace or move that 3 on the argument over. And then if I replace ln x with u, this is u squared minus 3u plus 2. I can factor, and then once I factor, set it equal to 0, replace it with natural log of x. Number 3 uses that same idea, but it's a little bit harder to see, okay? Again, on number 3, on the first one, the squared is on the exponent, so I can rewrite that as 2 log x. Now, in order to factor, it has to be equal to 0, so I'm going to head and move that to the other side. So now, on this one, if you want to replace it with u, you can, but this one's actually kind of easy to see without replacing. Both of these terms have a log x in it. So what I can do is I can take log x and I can factor it out. So then I'd be left with log x minus 2. And since it's equal to 0, I can take each factor and set each factor equal to 0 and solve. So I get 10 to the 0 is equal to x, and I get log x equals 2, so 10 squared is equal to x. So x is 1, or x equals 100. All right, the other questions I wanted to look at, the rest of the ones on this first page should be pretty similar to some ones that you guys have done already. So the other one that I wanted to look at is the back of that same page, okay, those first 3 questions. So out of these ones, 16 is one of the hardest ones to see. It's not that it's difficult, a little bit tricky to see. I don't want to leave that one. So what's different here, this is not log x times log x. If you notice, this log of x here is actually the argument of the other log. So if I were to write this in exponential form, the base is 10, so 10 squared is equal to log x. So now I can solve that log, so I would have 100 is equal to log x. So if I wanted to solve this, then I would get 10 to the 100 is equal to x. Now 10 to the 100, that means 100 zeros. That's something we're not going to write down. So we're just going to leave that as 10 to the 100th power. Okay, 17 and 18 are not difficult by being log equations. 17 and 18 just review some concepts that we haven't, they review some types of equations we haven't seen in a little bit. So looking at 17, the way to solve this is hopefully pretty easy to see. I can condense those logs by multiplying the bases. What I'm going to do though is I'm going to rewrite those with fraction exponents. All right, so the cube root of x squared would be x to the 2/3. And then the cube root of x to the 4th would be x to the 4/3. 2 to the -3 would be 1/8. So when you are multiplying x to the 2/3 times x to the 4/3, you would add those exponents. So that gives you x to the 6/3, which is x squared. So then at this point, since I have equivalent logs, I can just set the arguments equal. In order to get x by itself, I would square root it. The negative square root here actually could work because if you plug it back into the original, you're going to square it, which is going to turn it back into a positive. So it's not going to give you a negative argument. So it is plus or minus the square root of 1/8. Okay, the square root of 1/8 would be 1 over the square root of 8 because I square root the top and bottom, which I would rationalize. So I get root 8 over 8, and even more than that, I can simplify that to 2 root 2, which would just be root 2 over 4. So that is the rationalized version. Okay, so again, the first step here is pretty normal for what we've seen for log equations. Remembering your exponent properties and to get to those parts is a little bit harder, and then the rationalizing is a little bit different. All right, so again, square root on the bottom, you would multiply by that top and bottom, and then simplify that square root. Again, 18, it's pretty easy to see what to do since these logs are equivalent. I would set those equal to each other. And then to actually solve this, then I would cross multiply. That'd be the easiest thing to do here. So if I cross multiply, I would have x minus 1 times 3x minus 7, x minus 2 times 3x minus 1. Distribute. Okay, and then set it equal to 0. So my x squareds are going to go away. I'm going to get 3x is equal to 5. So x is equal to 5/3. The problem here, I need to take that answer, plug it back into the original in both equations. If I do 3 times 5/3 minus 7, okay, over 3 times 5/3 minus 1, that is going to give me a negative answer, okay, a negative argument. So because that gives me a negative argument, it is not an answer, which means this actually has no solution. All right, the last one I want to work on is the one I actually just crossed off, and it is this one right here. Now, this one's not that difficult to do, but again, the notation looks a little bit different because each log is inside of the other log. So we're going to start with the inside-most log, okay? Log base 2 of 16. So log base 2 of 16, I can evaluate. 2 to the something power gives me 16. That would be 4. So what I circled there, that whole thing is the same as 4. So I'm going to rewrite this and just replace it with 4. Now I can evaluate this inside part. So log base 2 of 4. So 2 to the something power is 4. That's 2. So log base 4 of 2. And then the last one I can evaluate, again, same way. 4 to the something power is equal to 2. In order to get to 2, I would take the square root of 4, which would be the 1/2 power. So that's my final answer. Okay. The rest of the problems on here should be a little bit more similar to what we've been doing, so they should be pretty good review. Inverses we've been doing. The variable equations is the same process. You just make sure you solve for the variable that it's actually the one it's specifically asking for.